Just a second. Question number 15, doubt. Okay, we'll come to that. Okay, rate of change of the volume is, what is the question number? This one, question number 19. 9.4 exercise, question number 19. Okay, let me insert the equation. Rate of the change of volume, so that is dy dv upon dt, but it changes with respect to time. So dv by dt is given as constant, so I'll take that constant as k. Now what is the actual volume of the sphere formula? Is it balloon, right? Balloon is in the form of sphere, so volume of the sphere is 4 by 3 pi r cube, that is d by dt of volume, that is 4 by 3 pi r cube. So v value I am replacing, there is a volume formula 3 pi r cube, which is equals to k. So derivative of the volume, so derivative d by dt of volume, derivative of the volume with respect to time, because it changes with respect to time only. Now if I differentiate this one, what I will get? 4 by 3 is a constant, so that will remain outside. 4 by 3 pi, that will come outside because it is a constant term. So 4 by 3 pi, it will remain outside. Now derivative of r cube with respect to t. So derivative of r cube is x to the power of n formula, that is n into x power n minus 1, that is 3 into r square. R cube derivative is 3r square into, you have to multiply this with dr by dt, because you are differentiating r with respect to t, dr by dt. So this constant will be equals to k. I hope this step is clear for everyone. Just I am differentiating r cube as 3r square into dr by dt. Now if I simplify, I think 3 and 3 will get cancelled. Then I left with 4 pi r square, 4 pi r square into dr is equals to k into dt. This is what I'll keep, 4 pi r square into dr. Just I'm bringing this dt, denominator dt, to RHS side, so I'll get k into dt. Now if I integrate this one, okay, let's see what I'm going to get it. If I integrate on both the sides, if you want to write the statement, otherwise you keep as it is. Insert equation. I think if I integrate, no. If I integrate, I think I'll go back to my equation. Just a minute. Okay, no problem. Let's integrate this one on both the sides. If I put integrate here, you will get 4 pi r square dr. 4 pi r square dr is equals to integral. Here it will come k dt. So let's see what you will get if I integrate on both the sides and what you get here exactly. 4 pi is a constant, so 4 pi will remain as it is. Here I'll keep 4 pi as it is, no change. After keeping 4 pi into r square integration. R square integration is r power 3 upon 3. It will come as r cube upon 3. This is the integration of r square is r cube upon 3 is equals to k is also a constant. Now integral dt. Integral dt is t and plus some constant will come c. So we call this as equation number 1. Okay, so after getting it as equation number 1, now see the question one more time. What is the data is given? If initially its radius is 3, that means when you start the balloon start growing or increases its volume, initially the radius is 3 units. What do you mean by this? Initially radius is 3 means initially what is the time will be? Time will be equals to 0. That is when time is 0, then I have radius as 3. So substitute this r value and t value in equation number 1. So I'll get from equation 1, what do you get if I substitute t equals to 0 and r equals to 3? If I substitute r equals to 3 here, 1 3 will get cancelled. 3 square 9, 9 4 is 36, pi will come. So it will come as, I am writing it directly, just you can do your calculation. 36 pi is equals to, if I substitute t equals to 0, so k into 0 is 0, the c value, only just c will be left. So I got c value as 36 pi. So again, substitute c value in equation 1. So then how your equation 1 is going to change as, this will remain as it is. This will remain as it is plus 36 pi will come because c value I am replacing with pi. Okay, so you may call this as equation number 2. 4 by 3 pi r cube equals to k into t plus 36 pi. Now what you have to do is, one more condition is given in the question, just read it. After 3 seconds, then the radius is becoming 6 units. So when t equals to 3, then your r value is becoming 6 units. So again substitute this t value and r value in equation 2. We can write here from equation number 2. Let's see what you get if I substitute t value and r value. R is 6. If I substitute here 6, 72 will come after cancellation. 72 into 4, 288 pi will come. So I'm doing the calculation directly. Please do in our notebook properly. If I substitute r is here, 6 into 6 into 6. So 3 will get cancelled in 6 twice. So 36 into 2 is 72. 72 into 4, 288 pi. 288 pi will come, which is equals to, now t value is 3. It will become as 3k plus 36 pi. Now after this, what you have to do is, you have to simplify the equation and you have to find the value of k. So first let me bring the 36 to the left hand side. It will come 288 pi minus 36 pi. So what I get if I subtract 252, I think 252 pi, yeah, 252 pi is equals to 3k. If I find the k value, finally I'll get k equals to, I think 84 pi. Now you know the value of k also. Substitute this value of k in place in equation 2. So let me write here. Substitute k value in equation number 2. If I substitute k value in equation number 2, let me copy this equation number 2 once. So here in place of k, I have to replace as 84 pi. It is 84 pi. Now you can simplify. What you get, 84 pi into t. So t is there in equation 2, yeah, plus 36. Now at any given time, you can find the radius. If I know the t value, I substitute the t value and I'll simplify. If you want, you can simplify further this one. What are the cancellations will take place? Pi will get cancelled on both the sides. Then you have 4 upon, okay, let me insert the equation. 4 upon 3 r cube. 4 upon 3 r cube will come. 4 upon 3 r cube is equals to, you have 84t. I think 4 also will get cancelled. Just a minute. 4 also will get cancelled. 4 pi will get cancelled on both the sides. So here you will have 1 upon 3 r cube. Here 4 will get cancelled. 21t plus 9. Okay. So at any given time, you can always find a radius of the balloon. That's what the question they ask. Find the radius of the balloon after t seconds. So what will be the radius after t seconds? So this is the radius. If you want, you can send 3 that side. Then you will get r cube equals to 63t plus 27. Okay. So at any given time, you can always find a radius. Is this clear for everyone? Yes, students? Or anyone has doubt? Please say yes or no.
Yes, sir.
Oh. So like this, there will be a word problem questions where you need to be what is given, how to solve it. Here two conditions are given. Initial time, initial radius is given. So whenever they use the word initially, that means when time is 0. Initially means time is 0, then the radius is 3. When after 3 seconds means when time is 3 seconds, then the radius is 6 units. You can check whether this your answer is satisfying the given condition or not. For example, t is 0. If I substitute t equals to 0 in this equation, what do you get? R value. If I substitute t equals to 0, this 21 into 0 will be 0. R cube by 3 equals to 9. Then r cube equals to 27. Then r value will be 3. So it is satisfying the given condition. When t is 0, I am getting r is 3. So therefore your answer is correct. So we'll go to the next question, question number 20. What is given in the question number 20? See, in a bank, principal amount increases continuously at the rate of r percentage per year. Okay, find the value of r, that is the rate of interest or the percentage of increment, if 100 rupees double itself in 10 years. Means after 10 years, 100 rupees will become 200 rupees. So what I do is I'll just explain the solution so that you will be, yeah, typing will taking so much time. This is the 20th question. In a bank, principal increases continuously at the rate of r percentage per year. That is, rate of change of principal with respect to t is r percentage of the principal amount. So that's what they are given. If I take p as the principal amount, dp by dt. dp by dt means rate of change of the principal amount with respect to time is r percentage per year. R percentage means r upon 100 into principal amount. R percentage of what? R percentage of the principal amount. So dp by dt equals to r upon 100 into p. Now separating the variables, now you bring the p one term one side and t terms another side. So I'll get dp by dt equals to r upon 100 into dt. When I integrate on both the sides, so integral dp by dt equals to r upon 100 is a constant term. So we bring it outside, you will get integral dt. So 1 upon p integration is log p. Here you have log p, r upon 100 into integral of dt is just t. So you will get rt upon 100 plus k. Now here you have log p equals to RT upon 100 plus k. If I want exponential on both the sides, then p equals to, I think you have this formula. If log a equals to, let me write this formula once. Insert equation. There is no log terms. Not here, not here. Regular trigonometry. Oh, let me do something this way. Log a to the base b. Actually, it's not appropriate way to write. Log a to the base b. If I have equals to some x is there, then the same thing I can rewrite it as in the different way. A equals to b to the power of x. Okay. A equals to b to the power of x. This is the logarithmic formulas which we already studied once. I don't know whether you remember or not. Log a to the base b equals to x. Then I can write a equals to b to the power of x. So the same formula they used here. Here they have log p equals to some number is there. Then if you want p, here base is e. That's why it will went as exponential. P equals to e to the power of r by t rt upon 100 plus k. Everything is above of e as the exponent of e. Now what is given in the question here, it is 100 rupees is becoming 200 rupees after 10 years. So that means initial amount you are investing in the bank or somewhere is 100 rupees. Initial amount means, as again, when t goes to 0, that is the initial amount. When t goes to 0, your principal amount is 100 rupees. So that's the condition they used here. When t goes to 0, given that t goes to 0 when p goes to 100. So substitute these values here. If you want, let me write this step here. P goes to just few seconds now. P goes to exponents e to the power, let me put the bracket so that no confusion will be there. E to the power, what you have, RT upon 100 plus K. Fraction will come RT upon 100 plus K. This is what exactly they are given. The condition is after taking exponents. Now given initially the principal amount is 100 rupees becoming 200 rupees. That means your initial amount is 100 rupees. When I say initially, then the time will be equals to 0. So if I substitute these values in the equation number 1, if you want to give the equation number 1 here. So if I substitute here, I'll get 100 equals to, when I substitute t equals to 0, this r into 0 is 0, 0 upon 100 is again 0. So just I left out with e to the power of k. So here you left out with e to the, e to the power of k after substituting t equals to 0 in RHS, e to the power of k. So we call this as equation number 2. Now what is given second condition? Your amount is becoming double after 10 years. That means when t equals to 10 years, your principal amount is becoming double. Double means out of 100, double means 200 rupees. Okay. So substitute again these values in equation number 1. You can mention here from equation 1. Let's see what do you get. P value is 200, so you'll get 200 is equals to, let me write this entire step. 200 equals to, this is the equation. Now what is given here? R value, sorry, multiplication. T value is 10 years. I'll substitute T value is 10. T value is 200. Next step, what you can write here is 200 is equals to, here what you get is, this numerator 10 will get cancelled with denominator 100 as 10 times. So you'll get here r upon 10. This plus k, just tell me, can I write this way as multiplication into e power k. Here I am using that formula, a power m plus n equals to a power m into a power n. So that is the formula I use from the above step to below step. This is m value is r by 10, n value is k. So m plus n. So I written as e to the power of m into e to the power of n. Now what you can do here is 200 equals to, let me put this values as it is. What you can do is, in place of e to the power of k, here you can replace this value as 100, because we got in equation 1 e to the power of k value is 100. So here I am replacing this e to the power of k value as 100. Now what happens is, this 100 will go to the denominator, to the LHS. 200 by 100 is 2. So you have 2 equals to e to the power of r by 10. So in the next class, if I apply log on both the sides, you will get here log 2 is equals to r upon 100, sorry, r upon 10. Now log 2 value is given in the question. Log 2 value is 0.6931. 0.6931. So here you'll get 0.6931 is equals to r upon 10. Then r equals to, you'll get 6.931. So this is the rate of interest. Okay, that's what they ask. What is the r value? Find the value of r if 100 rupees becoming double itself after 10 years. Okay, so I got rate of change of the principal amount is 6.931 rupees. Percentage, not rupees. It is a percentage, because rate of interest should be in the percentage. Is this clear how we solved it? Yes, students?
Yes, sir.
What about others? Okay, yes. So like this, you can solve the next question. 21 is also about bank amount only, principal amount same way. 22, 23 right? So we'll move to the next topic, homogeneous differential equation. What do you mean by homogeneous differential equation is, uh, let me see where they are given the appropriate definitions.
Sir, question number 15.
Achha, you said question number 15, right? Let me see. What is question number 15? Find the equation of the curve passing through the point 0, 0, whose differential equation is dy by dx equals to e power x into sin x.
Sir, only the integration of e power x sin x into dx.
Okay. I think we need integration by factors here. You leave that question. We'll come to that integration by factors. We are not studied it. Like in the differentiation, you have uv formula, right? U into derivative of v plus v into derivative of q. Similarly, in the integration also, we have uv formula, integration by factor. We'll come to that part later, integration factors. Okay.
Yes,
So
sir.
leave this integration of 15%. We are not yet studied that topic. Okay. Okay. Homogeneous differential equation. How I define homogeneous differential equation is a function f x comma y. This is the just f x comma y means it is a function in terms of x and y. Is said to be homogeneous function of degree n if in this function in place of x I have to substitute lambda x and in place of y I have to substitute lambda y. After substituting lambda x and lambda y in place of x and y, then I must be able to write that function as lambda to the power of n into f of x comma y for any non-zero constant lambda. That I can say the given function is homogeneous, otherwise it is non-homogeneous. For example, if I take f of first function, f1 function I am taking as f of x comma y as y square plus 2xy. So let me write here. Uh, so we are putting here it as f of x comma y is equals to x square. I'm taking some random function x square plus maybe 2xy. Okay. So in the next step, what I have to do is I have to substitute in place of x, I have to substitute lambda x. In place of y, I have to substitute lambda y. So f of any lambda symbol, uh, beta, gamma, mu, theta, there is no lambda value. Here it is. Lambda x, let me copy this lambda x, comma, lambda y. Now what you get here it is, so as usual we substitute here it as lambda x whole square plus 2 into lambda x into lambda y, which is equals to, so if I expand open, I think everywhere lambda square will get common. So you can put here lambda square I have taken common from both the terms. Again you will get here it as x square plus 2xy. Okay. Because here also lambda into lambda will be lambda square. If I take lambda square common, here also lambda x whole square means we will get lambda square x square. So I can take lambda square common. Now this is in the required format, which is equals to lambda square into uh, lambda square into f of x comma y. So I can say given function is a homogeneous function. When it cannot be a homogeneous, if it is not a homogeneous, then we call it as non-homogeneous function. For example, let me change this question itself. If I put here lambda x cube in place of x square, if I keep x cube here, so my now function is f of x comma y equals to x cube plus 2xy. So here you get lambda x whole cube plus 2 into lambda x into lambda y. Now what happens here is, in the first term I get lambda cube x cube. Here we'll get 2 lambda square xy. So first term has lambda cube, second term has lambda square. So still I can take a lambda common. So then what happens here is you'll get uh, one lambda will be left out, and here x cube will be left out. Lambda x cube plus 2xy. So can I say lambda x cube plus 2xy will be same as f of x comma y term? It is not, because f of x comma y is just x cube plus 2xy. But here I have lambda x cube plus 2xy. One lambda is extra here. So in this case, this function f of x comma y is a non-homogeneous function. Okay. We call that function as non-homogeneous. If it is coming lambda to the power of n can be any number, into f of x y, then I can say it is a homogeneous function. Hope your difference is clear between the homogeneous and non-homogeneous functions. So here they are given multiple examples. For example, if I take cos y upon x, okay, cos y upon x, can you say it is a homogeneous or non-homogeneous? If I substitute in place of y lambda y, in place of x lambda x, both the lambdas will get cancelled. Again, I left with cos y upon x only. You said there is no lambda outside. You can write lambda to the power of 0. That you can always write. Here they clearly said where they mention the value of lambda. For any non-zero constant lambda, lambda can be any non-zero number. It cannot be 0. Lambda cannot be 0, but lambda to the power of n is there, so n can be 0, no problem. Okay, so those are all homogeneous functions. Now here they are given sin x plus cos y. If I put in place of x lambda x, I'll get sin lambda x plus cos lambda y. You cannot take lambda common because it is sin of lambda x and cos of lambda y. So lambda cannot be taken common. So that's the fourth function. F4 is a non-homogeneous function. It cannot be homogeneous. Now what is the use of homogeneous and non-homogeneous functions is we have standard method to solve a homogeneous function. What is that standard method? We will see now. And when we need required to solve this homogeneous and non-homogeneous functions, we will see. Okay. Uh, what? Now let me take one example so that show that the differential equation is homogeneous and solve it. So x minus y into dy by dx. Here it is example. Insert. These are the little bit of big questions. You have to be quick and show an x minus y into dy by dx. X minus y into dy by dx is equals to x plus 2y. X plus 2y. This is the question is given. Now can you separate, like in the previous exercise we brought all the x terms one side and we brought all the y terms another side. Can we do that? Can you bring x terms one side and y terms one side? You try at home. If you can bring in that way, you can solve the using any of the previous methods or previous ways which we used. But in this question we cannot bring x and dx terms one side, y and dy terms one side. That cannot happen. So in that case I have to check whether the function is homogeneous function or not. Okay, if it is homogeneous function, then we have a one standard method which to be followed and we can solve it easily. So here I can put dy by dx equals to, here you have x plus 2y upon x minus y. Okay, so then I have to put in place of x lambda x, in place of y lambda y, and see what do you get. If I substitute here, dy upon dx is equals to, here you have lambda is there. Let me copy lambda here. So if I substitute here lambda x plus 2 lambda y upon lambda x minus lambda y is substituted. Now you can take lambda common in numerator and denominator, so it will get cancelled. So you can write this as lambda to the power of 0 if everything is getting cancelled, so we can replace that way. And here you have x plus 2y upon x minus y. Okay. Okay, so it can be written as lambda power 0 into f of x comma y. So hence it is a homogeneous function. If it is a homogeneous function, now what we are going to do is, remember this step, we are going to substitute y equals to vx. For every homogeneous function, we have to substitute y equals to vx in the given function. Wherever y is there, y has to be replaced with vx. Now, before I do that, substitution y equals to vx, let me derivative this function y equals to vx with respect to x. So if I differentiate, I'll get dy by dx is equals to, here v and x, there are two terms, I have to apply uv formula. V into derivative of x, that is 1, plus x into derivative of v, that is dv upon dx. Okay, so dy by dx value, I got it as v plus x dv by dx. So what I do is, I'll replace here in this equation dy by dx, I'll replace it as v plus x dv by dx is equals to, here I have x plus 2y upon x minus y. So here also what I have to do is, I have to replace y value as 2 into vx. In the denominator also y value as vx. So everywhere I replace y values and dy by dx values, everything I replace. Now the entire question is in terms of v and x. Now what you can do here is, let's see, I keep your LHS as it is. I don't make any changes now. I'll make it in the next step. Or maybe what you can do is, okay, let me paste it. Uh, Keep this x dv by dx here itself, which is equals to, now look at these terms here, x plus 2vx upon x minus vx. If you observe carefully, x will get common in the numerator and denominator. Okay, I can take x common from numerator, from denominator, and I can cancel them. So after cancellation of x, let's see what you left out. You left out with 1 plus 2v upon 1 minus v minus v. From where you are getting this minus v? Here LHS you have v into 1 that I am transferring to the right hand side. So plus v will become minus v. Okay. Now let's see how and what will change. I can take the LCM in the RHS sign. That means your LHS is going to remain same for time being. So here you have x dv by dx equals to, if I take the LCM, LCM is going to be 1 minus v. What you get here, you have 1 plus 2v. Now here you have minus v into 1 minus v, because this denominator 1 minus v will multiply with this v. So v into 1 minus v. This is what we got in. Next step, still I keep this x dv by dx as it is, equals to, let's see how the numerator is simplified and what you get after simplification. Your denominator will be 1 minus v only. In the numerator, what you get, I think numerator I'll get it as 1 plus v, and this will be plus v square. You can cross check whether it is right or wrong. 1 plus v square. Okay, because this bracket will be open, minus v into 1 is minus v, minus v into minus v will be plus v square. Now you can see here all the, you can separate now all the x terms one side and all the y terms one side. How can you separate? Here it is. Let me bring over the terms one side. I'll show you what are the terms. Anyone can tell? So if I bring these all terms to the left hand side, it will become 1 minus v upon 1 plus v square will come to the denominator into dv is equals to dx upon x. Now all the v terms one side and all the x terms one side. See, this is the purpose why we are substituting y equals to vx. If it is a homogeneous equation and when we cannot separate x and y terms to the left and right hand sides, then that homogeneous equation will convert into a variable separable form where I can separate same terms one side. Now this one you have to integrate. How do you integrate? How do you solve it? That we have to see. Till here it is clear how this integration we have done.
Yes, sir.
So that is homogeneous equations method of solving. I think here we need some more methods. V plus 1. Okay. Now what I do is we have different methods to this type of questions we have to solve. For example, if I solve this one, what do you get? 2v. This 1 minus v is correct. Did I copy the question correctly? X minus y. Just let me check. Okay. So I think it's 11:44 now. Let me complete this question. A little bit variation will come. Okay. Now if I take the differentiation of the denominator, what do you get? The differentiation of the denominator is 2v plus 1. Okay. So here what I do here is 1 minus v. I will write it as v minus 1. That minus I have taken common. That minus I will keep here. Yeah. Okay, just I have taken the minus common. 1 minus v, I am writing it as v minus 1 because of minus is taken common, and the taken minus I kept here it is. Now if I do the derivative of the denominator 1 plus v square, I'll get 2v plus 1. So let's see, here we have to make little bit changes in the denominators. Yeah, so 2v plus 1 is required. What I do here is 1 by 2. Let me integration also include integral. See, certain steps it will come all of a sudden. You have to be very careful. It will be 2v plus 1. I put 2v plus 1. Then this will come as minus 3. Yeah. Can you check now? Your numerator will be as it is. See here what I have done is, if I differentiate the denominator, I am getting 2v plus 1 because denominator here we have is 1 plus v square. Its differentiation is 2v plus 1. So E required 2v, but in the numerator I have only 2. Okay, that's why I am dividing and multiplying with 2. What you can do here is, instead of all the steps at a time, 2v minus 2. We can put 2v minus 2, no problem. Just I am multiplying and dividing with 2. Dividing with 2 that I kept outside because it is a constant, and multiplying in the numerator is 2 into v is 2v, minus 1 into 2 is minus 2. But differentiation of the denominator is 2v plus 1. So if you want 2v plus 1, what I do here is, after 2v, I'll add plus 1 and I'll subtract minus 1. Okay. So adding and subtracting the same term is not going to change your equation. So minus 1 minus 2 will become minus 3. So that is the reason why I kept minus 3 directly. Okay, so we can do that step by step, which is equals to minus integral dx upon x, dx upon x. Now what happens here, it is, I'll take few more minutes. Insert equation. This 1 by 2 will remain as it is, and let me put the brackets. 1 by 2 into integral, here it will come 2v plus 1, 2v plus 1 upon, denominator is 1 plus v square. So here it will come 1 plus v square will come, minus 3 into integral 1 upon, this I am separating the denominator for both the terms, 1 upon 1 plus v square equals to, is equals to minus integral of 1 by x is log x, derivative of log x is 1 by x, so integral of 1 by x is log x plus c. Now this term 2v plus 1 upon 1 plus v square, this will become log f dash x by f of x, which is log mod f of x, which is equals to, here again let me insert the equation. So we have 1 upon 2, 1 upon 2 log mod, the denominator will come log mod 1 plus v square minus 3 into, so here we have to convert this into a plus b whole square will come, completing square method. Use the completing square method that you can integrate. For timing I'll keep it same, and then look at the time, is equals to minus log x plus c. Okay, after simplification, after this integration, try to solve this integration. You have to use completing square method, then you will get one of the formula, maybe 1 upon 1 plus a x square plus a square formula, some formula will come that we already studied. If you are not getting, I'll explain in the next class. And after that, you have to replace, say I taken y equals to vx in the substitution. So if I want v value, v will become y by x. So wherever v value will be there, v will be replaced with y upon x. Okay. So we'll continue further about these questions of homogeneous equations. Is that clear for today's class, or anyone has doubts?